The most dangerous thing on the deck of CVN-77 did not look like a weapon. It did not look like a missile launcher. It did not look like a gun system. It did not look like anything that belonged on the flight deck of a nuclear-powered aircraft carrier. It looked like a container, a silent, box-shaped module sitting on the USS George H. Bush, surrounded by fighter jets, helicopters, catapults, antennas, and the machinery of American naval power. To anyone walking past it, it could have looked temporary, ordinary, almost forgettable. But that box was not ordinary, because inside the new math of modern naval warfare, it represented something far more important than another weapon. It represented panic control. Not panic in the crew, not panic in the ship, but panic inside the old defensive model of the carrier strike group. For decades, the logic of a U.S. aircraft carrier was simple. Keep the enemy far away. Detect the threat early. Track it with radar, launch fighters or missiles. Kill it before it comes close enough to matter. That was the promise of the carrier strike group. Distance was protection. Precision was protection. Missiles were protection. But Hormuz is where clean theories go to die. The Strait of Hormuz is not a wide-open ocean where a carrier can calmly operate from a comfortable distance. It is a narrow, pressured choke point surrounded by drones, missiles, fast boats, surveillance networks, oil traffic, and political risk. Every mile matters. Every radar contact matters. Every mistake can become a headline. And in that environment, the threat was no longer just one advanced missile or one enemy aircraft. It was numbers. Cheap drones. Disposable drones. One-way attack drones built not to survive, but to force a response. That is what makes them dangerous. A drone swarm does not need to defeat the U.S. Navy in a traditional battle. It does not need to outmatch a destroyer. It does not need to sink a carrier by itself. It only needs to do one thing: make the Navy spend. And that is where the old equation begins to break. A carrier strike group is one of the most heavily defended formations on Earth. Around the carrier are destroyers, aircraft, helicopters, electronic warfare systems, radar networks, and missile batteries. On paper, it looks almost untouchable, but no ship carries infinite ammunition. Every defensive missile fired is one missile gone. Every interceptor, launched from a destroyer or cruiser, reduces the number available for the next attack. And in the middle of a fight, at sea, inside a contested theater, reloading those missile cells is not simple. It is not quick. And in many cases, it is not realistic. So the question is no longer just, can the Navy shoot down the drone? The real question is, how many drones can the Navy afford to shoot down before the defense becomes the weakness? That is the hidden danger of the swarm. One drone is a target. 10 drones are a problem. 50 drones are a calculation. 100 drones become a strategy. The drone does not need to be smarter than the missile. It only needs to be cheaper. It only needs to arrive in enough numbers to force the Navy into a losing exchange. A defensive missile like the ESSM is an extraordinary weapon. It is fast, precise, agile, and built to protect the fleet from serious airborne threats. Against a cruise missile or high-end attack aircraft, it is exactly the kind of weapon a carrier group wants. But against a low-cost drone, the victory becomes uncomfortable. The missile launches. The drone falls. The ship survives. And yet the enemy may still have won a small part of the larger battle. Because the Navy just spent a premium interceptor on a disposable machine. Do it once, and the system works. Do it again, and the cost rise. Do it in waves, and the strike group begins to bleed its own defensive depth. This is not weakness. It is arithmetic. And arithmetic is becoming one of the most dangerous weapons at sea. That is why CVN-77 needed something different. Not another missile. Not a larger launcher. Not a more expensive interceptor. The carrier needed a defensive option that did not come out of a finite magazine. It needed a way to destroy cheap threats without spending irreplaceable weapons. It needed a shot that could be repeated again and again, as long as the ship could produce power. That is where the laser enters the story. not as a science fiction superweapon, not as a magic shield, not as something that makes the carrier invincible. A laser is much more specific than that. It is a weapon built for one brutal layer of the modern battlefield. Cheap, small, low-end aerial threats that are dangerous, mostly because they arrive in numbers. A missile kills with speed, blast, and fragments. It intercepts the target and destroys it violently. That is why missiles are so effective, but also why they are expensive, physical, and limited. A laser kills differently. It does not explode. It does not chase the target with a rocket motor. It does not throw shrapnel into the sky. It focuses energy onto one point and holds it there. Heat builds. A surface weakens. A wing root burns. A battery pack fails. A control surface deforms. The drone loses lift, loses stability, and drops into the ocean. It is not dramatic in the Hollywood sense, but on a carrier flight deck, that is exactly the point. No missile plume, no debris cloud, no metal fragments raining down, no extra danger to aircraft waiting on the catapult, no foreign object damage threatening a jet engine. A flight deck is not just a runway. It is a compressed war zone. Fuel, weapons, aircraft, sailors, spinning engines, moving elevators, and live ordnance all operate inside a small, unforgiving space. A clean kill matters, but the laser's real value is not cleanliness. It is endurance. A missile shot costs money, takes space, and disappears the moment it is fired. A laser shot costs electricity, and on a nuclear-powered aircraft carrier, electricity is the one resource available in massive supply. That is what makes CVN-77 different from almost any other platform. A destroyer can carry directed energy. An amphibious ship can test it. But a nuclear carrier is in a different category. It is not just a warship. It is a floating airbase powered by reactors designed to move man-tons of steel across the ocean while supporting radar, communications, aircraft operations, and thousands of sailors. Connect that energy to a defensive laser, and the carrier gains something missiles cannot offer. Two. A magazine that is not measured only in tubes. It is measured in power. That does not mean the laser replaces missiles. It does not. And this is where the story becomes important. The laser is not meant to stop everything. It is not the answer to every ballistic missile, every supersonic anti-ship weapon, or every bad weather combat scenario. Fog, rain, smoke, salt spray, and atmospheric distortion can weaken the beam. The system has to keep the beam on target long enough to do damage. Speed, distance, material, and weather all matter. This is not fantasy. It is engineering. And every engineering solution has limits. But the Navy does not need the laser to do every job. It needs the laser to do the job that missiles should not be wasted on. Small drones. Slow drones. Cheap drones. Fiberglass drones. Disposable drones sent to drain the fleet. That is the role. The laser handles the bottom layer of the threat. The missiles remain ready for the top layer, the weapons that truly demand a kinetic response. And that changes everything. Before the laser, every incoming object forced the strike group into the same basic spending problem. A cheap drone and a dangerous anti-ship missile both competed for defensive attention. The threats were different, but the ammunition pool was limited. With a laser in the lower defensive layer, the system becomes more intelligent. The cheap target gets a cheap answer. The expensive threat gets the expensive interceptor. The carrier keeps its serious weapons ready for serious danger. That is the true purpose of the box on the deck. It is not replacing the missile. It is protecting the missile from being wasted. And that is the part most people miss. The Navy's interceptors were not failing because they were inaccurate. They were dangerous precisely because they were too capable. They could kill cheap drones again and again until the strike group began running out of the weapons it needed for something far worse. The laser gives the carrier a filter. It tells the defense system, not every target deserves $1 million answer. That may sound simple, but in the age of drone swarms, it is revolutionary. Because the swarm is not trying to fight fair. It is trying to turn fairness into a weakness. It is trying to make the most advanced fleet on Earth spend premium weapons on cheap machines until staying in position becomes too expensive, too risky, or too uncertain. The drone swarm does not have to sink the carrier. It only has to make the carrier leave. That is why Hormuz matters. Near Hormuz, the carrier does not operate in a vacuum. It operates in a narrow strategic pressure zone where every military action has economic consequences. Oil routes, regional deterrence, Iranian missile networks, surveillance drones, fast boats, allied shipping, and global markets all collide in the same body of water. A carrier sent there is not just a ship, it is a message. But a message only works if it can stay. If cheap drones can force the strike group to burn through missiles, then the swarm becomes more than a tactical threat. It becomes a strategic lever. It can pressure the Navy without defeating the Navy. It can challenge presence without sinking a ship. It can make the cost of staying higher than the cost of leaving. That is the battlefield CVN-77 moving into. And that is why the container mattered. It turned reactor power into defensive ammunition. It gave the carrier a way to answer cheap pressure with cheap fire. It helped preserve the missiles for the moment when only missiles would be enough. The laser does not make the carrier unstoppable. It makes the carrier harder to exhaust. And that may be the most important defensive upgrade of all. For decades, American naval power was defined by reach. Carrier aircraft could strike hundreds of miles away. Destroyers could launch missiles over the horizon. Sensors could track threats long before they arrived. The first of sensors, the entire system was designed to keep the fight at a distance, but drones are pulling the fight closer. They compress the battlefield. They crowd the radar screen. They force expensive ships to make repeated decisions against cheap threats. They attack not the armor of the carrier, but the patience, cost, and ammunition depth of the entire formation. So the future carrier does not only need range, it needs endurance under pressure. That is what the box represents. Not glamour, not prestige, not a weapon that looks powerful in a parade, but a weapon that answers the new question of naval warfare. Can you keep defending yourself after the enemy tries to make defense too expensive? Sometimes the biggest shift in war does not arrive as a new carrier, a new stealth fighter, or a missile with longer range. Sometimes it arrives as a plain container on a flight deck, a container that turns nuclear power into protection, a container that turns cost disadvantage into cost advantage, a container that tells every cheap drone the same thing. The carrier no longer has to spend a missile on you. That is why the old logic is changing. For half a century, naval power was measured by who had the better missile. But the next fight may be measured differently. Not by who can fire the most expensive shot, but by who can afford to keep firing when the sky fills with cheap machines. The biggest missile no longer guarantees control of the sea. The side that survives the math does.